Now we are going to study Newton's law. There are three Newton's laws. The first Newton's law say if an object is moving with constant velocity, why an object can be moving with constant velocity? What makes the object to keep moving with constant velocity? And the answer that Newton's give us is if an object is moving with constant velocity and it keeps moving with constant velocity means that the direction doesn't change and the magnitude of the velocity, this magnitude, the length of this vector doesn't change. If this is happening, it's because nothing is happening, because nothing is acting on the body. To make a change in the direction of the velocity, on this direction, or to make a change in the magnitude of the velocity, this amount of length, you need a force. So the first law says, if no force is acting on the object, the state of the object, his vector velocity, remain unchanged. Nothing changed. So if you see an object moving with constant velocity, when I say constant velocity, I say magnitude of the velocity, fixed, never change, and the direction of the velocity never change, you say this is happening because nothing is acting on the object. So let's go to the second law. The second law says what produces a change in the velocity? Change in the velocity is acceleration. What produces a change in the velocity is the force. A force acting on an object produces a change in the velocity, produce an acceleration. So when a force is acting on an object of mass m, it will produce an acceleration. Now, it comes the subtle thing. The amount of acceleration that it produces depends on the mass that is here. If the mass that is here is very big, the amount of acceleration will be very small. So the exact equation in vector form say that the force is equal the mass by the acceleration. So the force equal to the mass by the acceleration means that if the force is like this and the acceleration is like this, the mass should be how much? So the force is like this, and the acceleration is like this. The force is parallel to the acceleration, always. So the force is equal the mass by the acceleration. This is, in this picture, is due because 1, 2, 3, and maybe 4, or maybe 3.5. So the mass is 3.5. You see the acceleration. The mass is almost 4. So 4 times the acceleration, in this case, is the force. So the force is the mass by the acceleration. The force is measured in newtons, and is 1 newtons is the force that is acting on a mass of 1 kilogram and produce an acceleration of 1 meter per second squared. This is what it means 1 newtons. 10 newtons means a force acting on a mass of 10 kilograms that produce an acceleration of 1 meter per second squared. So let's go to write the equation. Force equal mass by acceleration. Force equal mass. What is acceleration? It's change in velocity divided by the change in time. Force by time produce m by delta v, produce a change in the velocity. The force acting on the time produce a change in the velocity. So we rewrite the equation. Force by time, m by v final minus v initial. We rewrite this equation. M by delta t equal m bf minus m v0, distributed property. But m by bf is the momentum, the final momentum, because we define the momentum as the mass by the velocity. And m by v0 is the initial momentum. And the change in momentum, p final minus p initial, is the change in momentum. So as a result, what we have seen is that force by time equal change in momentum. And this is the second law of Newton. Let's go to the third. One example can be like this. A mass of 100 kilograms is acting a force of 10 newtons. Find A. Well, the force produces acceleration. How you will find the A? You will write the equation force equal mass by the acceleration. So you will find the acceleration as the force divided by the mass. So now it's asked another question. If F is acting during 2 seconds, what is the change in the velocity? Wow! So you will rewrite this equation. A force by displacement by delta t equal m by delta v. What is asking you is what is the change in the velocity? I know the force, I know the time, I know the mass. Oh, I can find the change in the velocity to answer question V. Is the force by delta t divided by the mass. This is the change in the velocity. Okay, can you do it? And the third question say, is V0 is 5 meters per second. What is Vf after 2 seconds? Well, I leave you this. You will find delta V on part B, that is V final minus V initial. You have the delta V here. You don't know Vf, but you know V0. What is Vf? Okay. On the third law, I have sent you a video, but this is the summary. The force that 1 and 2 interact, there is an interaction, maybe it's a pushing or a pulling. The force acting on 2, on this object, on the second one, on Tom, due to the first, due to Alex, the first on 2 due to the first on Tom due to Alex, this force that is acting on Tom is the same force but opposite. It's the same amount of force but opposite on Alex. So Alex does a force on Tom to the right. Tom does a force on Alex to the left with the same amount. This is the third law of Newton. If it's not a pushing and it's a pulling, the force that Tom, the second one, is doing on one is like this, is going to the right. So the force that this one, Alex, is doing on Tom is to the right. And finally, and the equation is always the same, this one, F12 equal minus F21, the force acting on one, acting on one due, acting on two due to one. Okay, and now I want to say only that when the weight at when the Earth is acting, it creates a force, the weight going downwards. This is the force that the Earth is doing on the body, on the object, mg, going downwards. Now the object, the person, is doing a force on the Earth that is going up, is applied to the Earth, is going up. So this is the action, and this is the reaction. This is the force acting on the body, on the person due to the Earth, and this force, this one is the force acting on the Earth due to this guy. That's all.